Welcome back. This is the third lesson recording for IM1, January 20th, 2021. So we're still on to card number 15 of decimals. So I've just filled in Jada's column of representing what A sub n is. We start with 0.25 and then multiply the common ratio once here, twice here, 3 times here, then 4 times here. And then for the 10th term, we start with the first term multiplied by the common ratio 9 times. Now let's try to do Noah's column. 0.25 times what is that? Okay, well, we don't really know what that is. So let's go to the next slide. And hopefully we'll be able to figure that out. Oops. Alright, so we're going to be multiplying okay, so look at this. 0.25 times 3 this is 0.325 times Welcome back. This is the third lesson recording for IM1, January 20th, 2021. We're still up to card number 15 of decimals. We've just filled out Jada's column for where geometric sequence that starts with 0.25 and it's being multiplied by 3 each time, right? So we started with 0.25, and when n is equal to 2, that's the second term. Start with 0.25, the previous value multiplied by 3. For the third term, you start with the previous value, which is 0.25 times 3, then multiply by another 3, and so on. You're just continuing to whatever the previous value is, you're multiplying by 3. And by the 10th, you're multiplying 0.25 times 3 9 times. Okay, now let's see if we can generalize this in a more exponent form. Okay, so let's just copy the form here and let's start with the easy one that we can figure out. Okay, so here we go. Well, we know that for the third term, it's 0.25 times 3 times 3 is what? That's same as saying 3 to the power of 2, right? And this is same as saying 3 times 3 times 3 is same as 3 to the power of 3. And this is same as 3 to the power of 3 times 3 times 3 times 3 is to the power of 4. And for this one, we multiplied it 9 times. Okay, so it's going to be 3 to the power of 9. Now, can you see the pattern? 4, 3, 2. This is same as 3 to the power of 1. To the power of 1. Okay, then 4, 3, 2, 1. What do you think should be here? It is 3 to the power of 0. Okay, it's in the descending order. Now, do you remember what 3 to the power of 0? Anything to the power of 0 is same as 1. That's where this pattern comes in. It's really 0.25 times 1, which is just 0.25. That's what you should have. Now let's move on. Okay, verify your table. This is what you should have. And then card number 17. Okay, using the pattern in the table, write an equation to represent the nth term, a sub n. Your equation starts with a sub n is equal to, and use the variable n. Okay, so this lowest column is what we are interested in. Okay, what do we always started with 0.25. What is 0.25? It's really same as a sub n, right? Or a sub 1, I should say, a sub 1. This is a sub 1, or the first term, so we are going to copy this, and instead of writing n, I am going to write 1. A sub 1 multiplied by, okay, and what do we do? Whatever the common ratio was, and we're going to use the variable r, oh, actually, or we can actually write 0.25, because that's the first term, multiplied by 3 to the power of, okay, now this is the tricky part. For the second term, we multiply by to the 3 to the power of 1. For the third term, it's 3 to the power of 2. Fourth term, 3 to the power of 3. Do you see that it's always 1 less than the actual the value of n? So I need to put n minus 1 here. Okay, so that's going to be my equation. And the next card tells you that what the correct answer was. Okay? Let's get back to our slides and let's summarize what we should have discovered from Desmos activity. For the last geometric sequence example, you can think of it as a rich grandma is tripling your money each week. Okay, so for example, the week 1 you start with a quarter, and then week 2 she's tripling that. She's giving you 3 quarters and giving you 0.75 or 3 quarters or 75 cents, and then tripling that. Your however many you had, she's tripling that. So it's going to be 3 times 3, so that's going to be $6.75. And in this case, you had 9 to begin with, and then she's tripling that. However many you had, she's tripling it every single time. And so that's going to be 0.25 multiplied by 27, which is 20.25. Okay, and if you use a table, this is what you should have had. Okay, basically, okay, that's what the total amount you had, but whatever the previous number you had, you are multiplying by another 3, another 3, another 3. And you can write this in an exponent form as such, and notice that comparing what you're multiplying by, the common ratio to the power of 9, and n is 10. It's always 1 less. So that's the general form for this sequence. It's 0.25 times 3 to the power of n minus 1, where we're talking about the nth term. So we say the general equation is 0.25 times 3 to the power of n minus 1. So this is the generic formula that you can apply to any geometric sequence. So a sub n, if you're trying to figure out what is the nth term value, it's always going to be a sub 1. What does a sub 1 mean? It's the first term value. Okay, first term value multiplied by r, which is the common ratio, to the power of n minus 1 is the number of terms. Okay, so it's going to be always n minus 1. And you can use this formula to calculate any term in the sequence. If it's in position n, then I can use this equation to calculate its term value a sub n. So you're supposed to take notes here. Now let's use that form. Okay, find the first three terms for the sequence represented by this equation. Okay, if I have this equation, a sub n is equal to 2 times 3 to the power of n minus 1. Okay, if I want to find the first term, then in this case n is equal to 1, right? So that's going to be 2 multiplied by 3 is the common ratio, 1 minus 1, that's going to be 0. 3 to the power of 0. What's 3? Anything to the power of 0 is just 1. So it's just going to be 2. Let's find a sub 2, or the second term similarly. So in this case, we're using n to be 2. N is 2 here. So 2 times 3 to the power of 2 minus 1 is going to be 2 times 2 minus 1 is just 1, so 3 to the power of 1, which is same as 3, so it's 6. What about the third term? Again, you're substituting for n to be 3. So 2 times 3 to the power of 3 minus 1, that's 3 squared. And that's going to be 9. So 2 times 9 is 18. And you can continue this pattern. Using geometric sequence equation, find a sub 24 for the sequence represented by this equation. How would we do that? Okay, so I'm going to show you a calculator. If you're using your calculator on your phone, what do you do? So a sub n, say we are looking for a sub 24, that means n is equal to 24, right? So we're going to substitute n to be 24 in the right hand side. So we're looking for 3 to the power of 23 1.3 is the common ratio. 1.3 is the common ratio, and we're looking for the fourth term to be n minus 1. Alright, so then 4 is the first term, isn't it? Okay, so that means 4 is the first term, 1.3 is the common ratio, and n minus 1 is the exponent that we're raising by. So it comes down to 4 times 1.3 to the power of 23. How will we do the calculation? Okay, so what you would do is, remember, order of operation. We need to do the exponents first. That means we're going to do 1.3 to the power of 23. So we put 1.3, and then we need to raise it to the power of 23. You use this exponent tool here, button here. It's x to the power of y in this case. X to the power of y. X is what you've just entered. So you click this button now, and then it's waiting for the y value. So then you enter 23, and then you click equals, and that should give you 417.54. And then whatever that value is, then you need to multiply by. Okay, so then you multiply by 4, and that should give you 1670.16. Okay, so then writing geometric sequence equation, what is the equation for 3, 6, 12, 24, then continuing on a sub n? Okay, that's the nth term value. How do we do that? That is our general form. Find the common difference first. What is the common difference? We get the second number divided by the previous number. Okay, so that's going to be 6 divided by 3. That's going to be 2. So common ratio is 2. What is a sub 1? That's the first term value. That's 3. So that's going to be, equation is going to be 3 times 2 to the power of n minus 1. Okay, and this is what we did today. I would like you to try to do card number 22 for the confidence check. And that's it for today. Thank you for watching.